Okay, for this lesson, we are going to talk about coordinate proofs, quadrilaterals, and this is part 2. So we had part 1, which is all your information. Now we're going to do part 2, which is going to give us some examples to work from. Okay, so let's get started. Again, we're going to have a couple of highlighters here, a pen, and a pencil. So make sure you have those. Make sure you're writing everything down that I write down in the order. Okay? Here we go. So the first thing says there are 4 steps to completing coordinate proofs for quadrilaterals. And if you follow these steps, it should walk you right through it. So when you start going, I don't understand what to do, go back to these steps. It takes all the guesswork out of it. So the first thing is you want to plot and label the quadrilateral on the coordinate plane. The second thing you want to do is determine the slopes of sides, if applicable. Now that is only if you're dealing with a parallelogram or a trapezoid, those shapes, and if it's asking you for that. For a kite, maybe. The third thing you want to do is determine the lengths of sides, if applicable. Again, depending on what it's asking you to prove, you may or may not need to do this. And then the last one, it says write a statement that confirms or refutes the original problem. When I say the original problem, I'm talking about this that I just put a little marking around. That's your original problem. Okay, so let's do the first example. It says prove a quadrilateral with vertices A, -4, 2, B, -3, 1, C, 1, 1, and D, 0, -2 is a parallelogram. Okay, so we are looking to prove that it's a parallelogram. And we have to look back at our notes from part 1 to determine the items that a parallelogram has. But step 1 says plot and label the quadrilateral. So -4, -2 is going to be A. -3, +1 is going to be B. C, 1, 1 is going to be there. And D, 0, -2 is going to be there. And then I'm going to take my highlighter, my green highlighter here, and I'm going to connect the dots, connect the dots, connect the dots. So it looks like a parallelogram, but we have to prove it. Here's my B, here's my C, here's my D. Okay, so the first thing it says is to determine your slopes. Well, there are 2 ways to determine the slopes. I'll do the hard way first and then show you the easy way after that. The first way is your slope formula. So my slope for AB would be y2 minus y1. So I'm going to go 1 minus a -2 over -3 minus a -4. Now, right here, I see 2 negatives. These 2 negatives become positives. So then I get my slope is 1 plus 2, which is 3, over -3 plus 4, which would be 1. So my slope is 3 over 1. And I'm going to write that over here. The next line that I'm going to do my slope for, I'm going to draw a little box there, is I'm going to do it for CD, because CD looks like it might be parallel. And the slope for CD would be, C is 1, and D is -2. So 1 minus a -2 just looks like the exact thing from the top. And then 1 minus 0. So again, 1 minus a -2 gives us a plus sign right there. And then we have our slope of 1 plus 2 is 3 over 1 minus 0 is 1. So at this point in time, I put CD, I go 3 over 1, and I see that they are parallel lines. And now I'm going to look at BC, and it's a flat line. So for BC, my slope would be, there is 0 rise. So let's find the coordinates. B, 1, C1. So 1 minus 1 over, and then 1 minus a -3, which would be 0 over 4, because again we have two negatives which make a positive. And then for AD, I'm going to fit it in here. It's going to be the same thing. What is that? -2 minus a -2 over 0 minus a -4, which would be -2 plus 2 and 0 plus 4, which would be 0 over 4, which is 0. So right now, we know that they are parallel. Okay, now we're going to do the distance. And the distance, we can look at BC. That's really easy. 1, 2, 3, 4 units across. So BC is just 4 units across. AD is 4 units across. For AB, what I'm going to do is I'm going to make the Pythagorean theorem, use the Pythagorean theorem, and I'm going to make my slope triangle, which was another way that we could have found slope, right? My rise of 3 units, my run of 1 unit. So for AB, the Pythagorean theorem says 1 squared plus 3 squared is equal to c squared. That'll be 1 plus 9 is equal to c squared. Which is 10 is equal to c squared. Now, if we know that 10 equals c squared, square root both sides, you get c is equal to square root of 10. So, for this one, we get AB would be the square root of 10. And we don't have to take it down to a decimal because the distance is the square root of 10. When I look over at CD, I'm going to make the same slope triangle. And again, even though it's going in a different direction, we still have 3 units here and 1 unit there. So as we look at AB and then we look at CD, we have 1 squared plus 3 squared equals c squared. And if you can look, it's going to be the exact same problem. So c squared, and then c is equal to the square root of 10. Because something, the square root of something squared, square root of something squared is equal to itself. So again, the square root of 10. Now we have opposite sides parallel, and we have opposite sides congruent. So we have just proven that ABCD, quadrilateral ABCD, is a parallelogram. What I'd like you to do right now is to work on this second example. And I will start you off by plotting the points. M is 3, 1, 1, 2, 3, 1. N is 4, -2. O is -2, -4. And P is 1, 2, 3, -3, -1. And I will connect the dots with a highlighter. And in this case, they want you to prove that the quadrilateral is a rectangle. So again, look back at your notes from part 1. Determine what you need to do in order to prove that it's a rectangle. Slopes are going to be involved. Distance is going to be involved. Good luck, and we'll go over it in class. If you have any questions, watch the video again, and then ask your teacher